We have already gone through the basics of quantitative analysis. Please note, whatever the process, all involve the slow addition of one reactant to another until one is depleted. After scanning through the procedure and locating the reagents, run through this checklist before starting the experiment. 1. For titrations, identify the titrant, and where an indicator is used, be familiar with the color change at the endpoint. 2. Understand the reaction process taking place, and where applicable, write the equation of the reaction if not provided. Last and most important, you should know the right significant figure for each apparatus used in a measurement. For example, burette volumes are recorded to 2 decimal places. During the experiment, reduce personal errors, like losing a reagent during preparation and transfer, or overshooting the endpoint in a titration. Such errors will affect the accuracy of your results. Also, in most experiments, more than one run is necessary, and in such cases, your results should be consistent. Poor precision results mostly from personal errors. Put it in mind, low precision and poor accuracy will score you very low marks. After recording your results, calculate the average volume of the reactants used. The average is calculated using the closest values. If not stated, the first experiment is always a trial run. Then, calculate the moles of the standard reactant whose concentration is known, then use the mole ratio from the reaction equation, to calculate the moles of the unknown reactant, or product where applicable. Now, we can apply the concepts we have learned to approach a UCE paper. From the question we note the following. 1. Ba1 is impure, therefore, it cannot be the standard. 2. Ba2 is the standard solution. 3. The reaction is an acid-base neutralization process. Neutralization processes are exothermic, therefore, the temperature raises wherever you add little the acid to the base. It will raise until all the base is consumed. This is the end point. After this point, the next drop of the acid added to the solution will cool it, and thus lowering the temperature. Therefore, you will plot a graph of volume of acid added versus temperature, and use the highest volume before the temperature drops as the end point. We will use my hypothetical graph. Please note the following. Your graph must have a title, the axis should be labeled, and choose a scale which covers 3/4 of the graph paper. As previously explained, after obtaining the volume of acid used from the graph, calculate the moles of the standard solution, Q, in C1, then the moles of the second reactant, R, using the mole ratio in C2, then the rest.